Calculus boys, we are going to be talking about lesson 62 today, which is work, distance, and rates, and how they relate to calculus. So, in your science classes, you have probably talked about work, and I would guess that you know work as the formula force times distance. That's what I would expect you guys to know about it. So, the example here is, for example, if a block that weighs 3 newtons is moved vertically upward a distance of 4 meters, 12 newton meters, or joules, of work is done. And so the idea that you're multiplying the 3 newtons, the force, times the distance of 4 meters gives you the 12 newton meters, also known as joules. In integral calculus, instead of using force times distance to equal work, in integral calculus, we're going to say the integral of force is equal to work. So given force, you can find work. And that's what we're going to look at. So let's look at example 1. A steady force of 50 newtons is applied to an object to move it 1,000 meters in the direction of the force. What is the work done by the force? And so obviously in your typical science class, this would be a very basic multiplication, and as we get to others, we will have more equations that we'll have to work with. For a visual descriptor here, I just want to do a basic, that's a bright green, I forgot about that. Hopefully that is viewable, but the idea that the x-axis acts as your distance, and the y-axis acts as your force. And so if we have 100 meters and 50 newtons, to find the work, so the idea of work, if you recall, is force times distance. And so if you look at those two, the work is represented within that box. And so thus you do the 50 times 100. Now for calculus, we're going to do the integral. And so we have a force of 50. So in order to find work, we're going to do the integral of 50. Well, okay, let me backtrack just a moment there. What I really was thinking is we're going to do the integral of force to find work. So the integral of force dx. Except notice we were given an integral, or a force of 50. So we're going to be doing the integral of 50 dx. What are our boundaries? What are our starting and beginning points? And the object moves 100 meters in the directions of the force, so the distance from 0 to 100 is your direction and thus your boundaries. So, what is the integral of 50? And add a variable there. So the integral of 50 is 50x evaluated between 100 and 0. And if you recall, using the fundamental theorem of calculus, plug in, I wrote the wrong thing. Are you guys yelling at me right now? I'm struggling. The integral of 50, did I say the right thing? I really don't know. So the integral of 50 is supposed to be 50x, sorry about that, evaluated from 100 to 0. And so plugging in our 100 and then our 0 and subtracting them, 50 times 100 minus 50 times 0. And you end up with the 50 times 100, which is 5,000. And again, because it's work, it's going to be 5,000 joules is what I'm going to use as my label. Hopefully that made some sense, even though I had a few little mistakes in there. I caught them all, I think. And again, that was based on our given of a force of 50 and a distance of 100, and they wanted to know the work. Okay, let's try example 2. I'll try and curb my mistakes here. A variable force F equals 1/2 x squared newtons is applied to move it 6 meters in the direction of the force from x equals 0 to x equals 6. What is the work done by the force? So what is the work done by the force? Well, what do we know about work? We were just talking about work is the integral of force. So in order to find work, I'm going to do the integral of force. Notice in this case they give me a force of 1/2 x squared. So we're doing the integral of 1/2 x squared dx. And then they also say in the direction of x equals 0 to 6. So my boundaries will be 0 to 6. Okay. Think about your integral of 1/2 x squared. Remember, you're adding 1 to the power and dividing by the new power. So my power becomes x to the third, and I'm dividing by 3, so that really becomes 1/2 times 1/3, which is 1/6. So 1/6 x to the third, evaluated from 6 to 0. Okay, to do the math, fundamental theorem of calculus, we plug in 6, plug in 0, and subtract. So 1/6 times 6 to the third minus 1/6 times 0 to the third. 6 to the third is 216, I believe. Divided by 6 takes us back to 36. The 0 obviously will not mean anything, and so we get an answer of 36. Again, we are asking for work, so it's 36 joules. Okay. Moving along. Example 3. Notice it starts off by saying, in example 62.2, how much work was done by the force in moving the object from the 4 meter mark to the 6 meter mark? So we have the total 0 to 6, but we want to break it down and know just the amount of work done from 4 to 6. What does that mean? We change on the previous problem. And basically that means we just have to change our boundaries. They're giving us new boundaries. So again, we're doing the integral of 1/2 x squared dx. The difference is this time it'll be evaluated from 6 to 4. We already did the integral up above. The integral of 1/2 x squared is 1/6 x to the third, evaluated between 6 and 4. So 1/6 times 6 to the third minus 1/6 times 4 to the third. Well, I already talked about the fact 6 to the third is 216, divided by 6 is 36, minus 4 to the third would be 64, divided by 6 does not divide evenly, so I'm going to write that as 64/6. Well, if I am trying to subtract these, and the 1 is a fraction, I'm going to have a common denominator. So I can think 36 over 1 minus 64 over 6. I can get a common denominator of 6, or you may notice that 64 over 6 would reduce. They would both divide by 2, and that would be thirds. So I'm going to go for a common denominator of thirds, if you don't mind. If you'd rather do sixths, go for it. We go for thirds. 1 times 3 is 3. 36 times 3 is 108. And then the 64/6, divide them both by 2, we'll have 32 over 3. So 108 over 3 minus 32 over 3. 108 minus 32 is 76, keeping my denominator, 76 thirds joules. And again, that falls into the category of problem where it is good to practice that type of problem without picking up the calculator. So, you saw the problem we did in class the other day that was a non-calculator problem. This is a much easier version of a non-calculator problem. Okay, example 4. Hooke's law for perfectly elastic springs says that the force on a spring is proportional to the displacement of the spring from the position of rest. Or, in other words, F equals kx. The constant k is called the spring constant, and x represents the displacement of the spring. If the spring constant for a spring is 1/2 Newton per meter, so spring constant for a spring is 1/2 Newton per meter. How much work is done in stretching the spring from 3 meters to 4 meters? Okay, so they're asking me to find work. Again, for what, the fourth problem? Work is the integral of force. Now, in this case, for Hooke's law, they give us an equation for force, F equals kx, where k is the spring constant. And if you read a little farther, what does it say our spring constant is? That is 1/2. So we're going to be doing the integral of 1/2 x dx evaluated between 3 and 4. And that is because F equals kx is going to be F equals 1/2 x. Okay, integral of 1/2 x. Add 1 to the power, and it is x squared. Divide by that new power of 2. So you end up with 1/2 times 1/2, which is 1/4. 1/4 x squared evaluated between 3 and 4. Now, a thought here. I don't know if you'll like my thought or not, but up above on the previous problem, when we filled in the 6 and 4, I kept the 1/6 with both pieces. And so we did 1/6 times the 6 to the third minus 1/6 4 to the third. Here, I'm going to do this slightly different, that we can still do the same thing, 1/4 times 4 squared minus 1/4 times 3 squared. But another thought, when you have a constant out here, so we have that constant of 1/4, you can keep the 1/4 out front and then just plug in the x values. This only works because it's a single term. So I can do 1/4 times 4 squared minus 3 squared. Now, if you don't believe me and you don't like this, then go back and do it the other way. Do 1/4 times 4 squared minus 1/4 times 3 squared. In mine, I feel like the math might be a little easier. 4 squared is 16. 3 squared is 9. 16 minus 9 is 7. Times 1/4 is going to be 7/4. And again, we were asked to find work, and so it's 7/4 joules. Okay, so hopefully this work is making sense here. Again, work is the integral of force. Okay, next page if you're ready. 2 more examples. Shanna calculated the velocity of an object would equal, and you will notice I have slightly edited that. I think it's supposed to say 1/2 t squared plus t. If you're looking at your paper right now, I think it says plus 1. So please make that equation 1/2 t squared plus t. Meters per second, where t represents elapsed time in seconds. How far would the object travel between the 5th and 7th second? Okay, so going a slight different direction, we're being asked to talk about velocity. Calculate the velocity of an object is 1/2 t squared plus t meters per second. So this is velocity, where t represents elapsed time in seconds. How far would the object travel between the 5th and 7th second? So if we're asking how far would the object travel, we are looking for what I would say as accumulated distance. Okay, accumulated distance, because we're accumulating the different distance between 5th and 7th seconds. Okay. We're being asked to find distance. We're given a velocity formula. What's the connection that you know? Normally, if we're given distance, we take the derivative to find velocity. Well, if we are given velocity, how are we going to find distance? We are going to have to do the integral. So we're going to do the integral of velocity. Integral of 1/2 t squared plus t dt, evaluated from 5 to 7. Okay, start by taking your integrals there. 1/2 t squared, we're going to add 1 to the power, makes it t cubed. Divide by that new power of 3 makes it 1/6. So 1/6 t cubed plus integral of t, you all know as 1/2 t squared, or t squared over 2 if you prefer. And this is going to be evaluated between 7 and 5. Okay, this one's going to take a little bit of careful math. So, plugging the 7 in first, 1/6 times 7 to the third plus 1/2 times 7 squared. I'm going to put that in parentheses. Then, fundamental theorem of calculus says I subtract, and in parentheses it's going to be 1/6 times 5 to the third plus 1/2 times 5 squared. Seven to the third, 343 times a sixth, so we're going to have 343 over 6 plus 7 squared is 49 over 2. 49 over 2. Minus 5 to the third is 125 over 6. Now, if you will, notice I didn't put parentheses. So rather than saying plus, I was going to distribute the minus and say minus this other fraction as well, which is 5 squared over 2, or in other words, 25 halves. Now, I don't know if you guys see it or not, but denominators of 6 and 2. My opinion would be to get a common denominator of 6. So if I take 49 halves to 6, multiply by 3, 49 times 3 is 147. So that's 147 sixths. On this one down here, if I multiply by 3, it's going to become 75 sixths. So now I'm doing 343 sixths plus 147 sixths minus 125 sixths minus 75 sixths. So The first two are going to be 490 over 6. This is going to be minus 200 over 6. So 290 over 6, both even, so they'll both divide by 2. 145 over 3. And what was I finding? This was finding the distance. So this is going to be 145 thirds meters. If this is a situation where you need to divide it out and get a decimal, if I recall correctly, it's 48.3 repeating. Or in other words, that'd be 48 and a third. One more example. Water leaked from a tank at a rate of R of t equals e to the negative t gallons per hour. How much water leaked from the tank during the first 10 hours? So, we talked about in our AP practice, we talked about a problem with a rate. If you recall, we did the Riemann sums with it. Not doing that here. But water leaked from a tank at a rate. We want to know how much water leaked. So the water leaking, you can kind of compare it to like a velocity because it's a gallons per hour. And then we're just trying to find how much. So we want to know how many gallons over those first 10 hours. So if you see where I'm leading you, I'm trying to say that in order to find how much water leaked, we're going to have to do the integral. So we're going to be doing the integral of our rate, e to the negative t dt, over what period? And you'll notice it says during the first 10 hours. So during the first 10 hours is from time 0 to time 10. The integral of e to the negative t. Well, integral derivative of e to any power is always e to the said power. But if you think about what do we have to compensate for, the derivative of negative t would be negative 1. And to compensate for a negative, we use another negative. So we're doing negative e to the negative t evaluated from 0 to 10. Substitute in your values. So negative e to the negative 10th minus negative e to the 0. Well, clean it up some. Negative e to the negative 10th minus negative makes it plus. Anything raised to 0 is always 1. And depending on the situation, this would be your exact answer. In other words, the answer you would get without a calculator. If you plug this into the calculator, you get a lovely decimal, 0.9999546,001, which is approximately what? 1. And this is 1 gallon because we were asked how much water had leaked from the tank in the first 10 hours. So 1 gallon. Okay. You know your assignment is to do problem set 62, and that will be due Monday. So on Monday, plan to have problem set 61 and 62 ready to go for me. Feel free to email me with any questions or issues. Otherwise, I will talk to you Monday. Have a good weekend.